guys, this is Edexcel Maths, and today we're going to look at quadratics. The first thing you need to know is that every quadratic equation takes this form. What you might have come across with is when a equals to 1 in IGCSE. Let's give this an example. For example, x squared minus 2x minus 15 equals to 0. Then you would think that a is 1 and c is minus 15. Then a times c is minus 15. And you know that b, the corresponding b, is minus 2. Then you would think, what multiplied by what give us minus 15? It adds to give minus 2. Then you would know it's 3 times negative 5. So you would write it in this form. X plus 3 times x minus 5, and you would set it to equal to 0 in order to find the value of x. Then you would know that either x plus 3 equals to 0 or x minus 5 equal to 0. And you will end up with x equals minus 3 and x equals to 5. But what if a does not equal to 1? Then let's look at an example. 6x squared plus 13x minus 5 equal to 0. A is 6, B is 13, and C is negative 5. You know, AC is negative 30 and B is 13. Then you would think, what multiplied by what gives us negative 30 and adds to give 13. And you would know it's 15 times negative 2. And write 15x minus 2x. 15 minus 2 is 13, and 15 times negative 2 is negative 30. Then you would put the minus 5 down and set it to equal 0. Then you would know that we can separate these two parts into this and this. And you would take out 3x from this equation here, and 2 times 3 is 6, 2 times x is x squared, and plus 3 times 5 is 15, and then minus, you would take out a minus from this part, and you will get 2x plus 5 and equals to 0. Since they both have this part, so imagine that there is a 1 here. So you would write 3x minus 1 times 2x plus 5 equal to 0. You would set 3x minus 1 equals to 0. Then you know that 3x equals to 1 and x equals to a third. Then you would know that 2x equals to minus 5 and that x equals to negative 5 over 2. So that's the solution for x. And now we're going to look at the quadratic formula. First, you need to put it into the form ax squared plus bx plus c equals to 0. And simply substitute the value of a, b, and c into the formula. This quadratic formula is usually used in situations where equations cannot be simply factorized. But if equations can be simply factorized, then factorization is much easier than this equation. The next thing that you need to know is how to put an equation into a completed square form. And let's give an example of this. X squared minus 3x equals 2. Then you would have to substitute each value into the formula and simplify. What I always try to do is not to memorize the formula, but instead to understand it. And here's a proof of completing the square. First of all, we need to imagine completing the square as to finding the area. First of all, you need to find the area of the rectangle, which is x squared plus bx. And this area is equal to a square with sides x plus b over 2. And the area of the square is x plus b over 2 squared, but then you want to find the unshaded region, so you need to subtract the shaded region from the unshaded region. So the shaded region is b over 2 squared. And here are some terms in which you need to get yourself familiarized with. First one is domain, and domain basically means inputs for a function, and the second one is range. Range is basically the outputs for a function. Let's look at what we mean. If the domain is 3 and the function is f of x equals to x minus 1, then the range will be 3 minus 1, which is 2. Another very important definition is roots of a function, which basically means the values of x for which f of x equals to 0. And let's see what we mean by this. If we need to find the root of x squared plus 3x plus 2, then we will have to set it to equal to 0. Then we will factorize it, and we will get that x equals to -1 and x equals to -2. Now we're going to look at how to draw a quadratic graph. First of all, you need to identify its shape. If a is bigger than 0, then it will have a positive parabola, so facing up, and if a is smaller than 0, then the parabola will be negative, facing down, but a cannot be equal to 0. The second thing you need to find is the point of intersection with the x-axis. In order to do that, you need to set y equals to 0. And the third thing you need to know is the intersection with y-axis. And to do that, you need to set x to equal to 0. And the last thing is to find the turning point. In order to find a turning point, you need to know the shape. And if it's bigger than 0, if a is bigger than 0, then we're finding the minimum point. And if a is smaller than 0, we're finding the maximum point. And in order to find the exact coordinates of the turning point, you need to write the equation of the graph in a completed square form, in which P and Q will be the coordinate of the turning point. And let's take a look at an example in which we have to sketch the graph of y equals to x squared minus 5x plus 4. First of all, we know that a equals to 1, so we know that the shape of the graph is positive and facing upwards, and we're trying to find the minimum point. And when x equals to 0, then substitute it in, we get that y equals to 4. And when y equals to 0, we will have to factorize the equation, and we get x equals to 1 or x equals to 4. Then we will try to complete the square of x squared minus 5x plus 4 in order to find the minimum point, which is the turning point. And we get that the minimum point is 5 over 2 and negative 9 over 4. Then we just have to plot all this information onto a graph. You need to remember that you have to label your axis and label any coordinates that you know and draw a smooth curve. And the very last thing that we're going to look at is the discriminant, which actually comes from the quadratic formula, which is the thing under the square root. If b squared minus 4ac is bigger than 0, then it has two distinct real roots. If b squared minus 4ac is equal to 0, it has one repeated root, and if b squared minus 4ac is smaller than 0, it has no roots. Let's take a moment to look at why this is the case. Since b squared minus 4ac is under the square root, so if it's bigger than 0, it will have two distinct real roots. And if it's equal to 0, then it will have one repeated root, which is 0, because 0 squared equals to 0. And if it's smaller than 0, it's just negative, and it's impossible to have a negative number under the square root, so it'll have no real roots. And let's look at an example of this, which is to find the range of values for k for which x squared plus 4x plus k equals to 0, and has two distinct real solutions. And when we see that it has two distinct real solutions, it means that b squared minus 4ac is bigger than 0. So you have to just substitute the value of b, a, and c into it, and we'll get that 4 squared minus 4 times 1 times k is bigger than 0, and so k is smaller than 4. And this is the end of the summary for chapter 2. Thanks for watching. See you next time.